Hi everyone, this is week 4 day 1 video. Sorry, I had to record this again because while I was solving this I dropped something and there was a huge noise and I had to leave. So that's why we're gonna start with the first example already solved and I'll just walk you through it verbally. So a lot of the things that we need for this week, we have developed the tools and the methods that we're going to use. So it's going to be a lot of examples that we do this week. Now we're going to continue looking at word problems using trig ratios. Specifically, in cases where a right triangle is not obviously visible, we look at how we can construct it by using some of the properties we've learned prior to this week. So in this problem, you have to find angle 1. Since there is no right angle obvious, what I do is I extend this line horizontally and this corner here down vertically. Label this as H and X. The reason I'm doing this is the backward thinking here is for finding angle 1, I need a right triangle with these two sides. Now these two sides can be found because H is just this entire length minus the small gap. So it's 19 minus 7.3, which is 11.7. Similarly, X is going to be all of this length subtract the smaller length. So it's 32.78 minus 14.35, which is 18.43. Finally, in this right triangle, using SOHCAHTOA, I know I have the opposite and the adjacent. So tangent 1 is opposite over adjacent is H over X, is 11.70 over 18.43. So angle 1 is going to be inverse tan of this expression, which is going to look like that. Now, to make sure my answer is in the correct format, which is degree, you look right up here in the calculator. So, for example, mine says DEG, that means it's in degrees. So that gives you the angle. Let's look at a second problem. Again, I actually started talking about this problem, so I have a little bit of construction already going on here. It says find the length of this fence from point T to R, and this is part of a circle whose radius is 70 meters and T is tangent to the circle. Now this is an important piece of information because if you recall, radius is always perpendicular to the tangent, which means I already have a right triangle here. And I have this length, and I also have the length OT because that's the radius, which is going to be 70 meters. So I'm working with this angle right here, opposite and adjacent, which means once again I'm dealing with a tangent situation. So tan of 28.4 degrees equals opposite over adjacent, which is 70.0 over unknown, right? Let's say I call this x. Cross multiply, right? This is over 1, cross multiply x times tangent 28.4 equals 70.0 divide, because our goal is to isolate the expression for x. So this cancels out. So x equals, and I plug that in, 70 divided by tangent of 28.4, again making sure it's in degrees, gives me 129.46, what's the unit? Meters. So that is the amount of fencing that would be required. Next example says compute the depth of the cut y, which is going to be this length here, in this machine block, and you are given a bunch of lengths. Now again, this is similar to the first example in the sense that I can create a right triangle right here, and this is going to be y, and let's say I call this x. Now I can find x because I know this entire length is 96.35 and I know this length from this edge to this edge A, and I know the length from B to this edge. So x is going to be 96.35, subtract 27.2, subtract another 27.2. Okay, so let's find how much that is. 96.35 subtract 27.20, subtract 27.20, 41.95. So x is 41.95 millimeters. All right. Now what else do I know? I need to know this angle, but I actually don't know this angle because this is not 90 or 180, so I can't just subtract. So let's see, what else do we know? We're given AC equals BC, which means if I look at this triangle, CAP, these are equal, which means these angles have to be equal. So this is an isosceles triangle situation. In an isosceles triangle, two angles are equal. But I know this is 71.80. So if I let angle A equal angle B equal x, in this triangle I know all the angles have to add up to 180. So x plus 71.80 should equal 180, which means 2x should equal 180 minus 71.80, which is 180 minus 71.80, 108.2. So x equals 108.2 divided by 2, which is 54.1 degrees. Or maybe let's call this x prime because we already used x here. Okay, so I find this angle is 54.1 degree. Now how is that going to help me? I still don't know this angle. We're going to use another piece of information, or another piece of another tool we've learned before. Now the top part is parallel to the line containing x, yeah? And the line AC, if you extend, is like a transversal, which means these angles are equal because they are alternate interior angles. So since they're alternate interior angles, if this is 54.1, this is also 54.1. So now in this right triangle, I know this angle is 54.1. I know this length x, and I'm trying to find y. So once again, it's a opposite adjacent scenario, which means I go ahead and I write tan 54.1 is y over x. So y equals x times tan 54.1. I plug in the value. I found x to be 41.95 previously. So 41.95 times tangent of 54.1 gives me 57.95 millimeters. Okay, so here we used two separate things to find this angle. Yeah, we use the property of isosceles triangle, and we use the property of parallel lines and transversal. Okay. Next example says determine the length x in this template. So x is right here. That's the flat part. So there's a lot of information going on over here. So let's strategize. Now I know this entire length is 8.5. These lengths are known, so if I subtract, I'm left with what's in the middle. And then to find x, all I need, the missing part are just these. If I draw these vertical ones here and I make them right angled, let me call this A and this B. Then my goal would be find x via A and B. Why? Because I know x is this entire length 8.500, subtract these corner ones 0.75, 0.75, subtract A, subtract B, which is 8.5, sorry, 8.500, subtract 0.750, subtract 0.750, 7 minus A minus B. So my new goal now is to find A and B. Now once again we can use the parallel property here. This is 34 because alternate interior. So let's focus on this triangle right now. Let's see. Okay, so here we know 2.870 and 3.900, which means that if you subtract these, what you get is a different height. It's the height over here. That's the height between these 2 points. Okay, so that still does not give me anything about the triangle. Okay, maybe this labeling is not correct. I'll get back to this problem. Let's look at the last example. Compute the straight line distance between the points A and B, where the diameter is given to be 68.25 feet. So this is a circle. That's this angle is 227 degrees. So the radius is 68.25 divided by 2, which is 34.125 feet. And I am trying to find the straight line distance between A and B. So now recall, if I complete this circle, then AB is a chord. Now what we know about chords is, if you take the center of the circle and you drop a perpendicular, then AC equals BC, because line joining or perpendicular from center of circle to a chord bisects it. Okay. Now we know this length, and now we need to find the angle. Now finding the angle is also fairly easy. If this is 227, all of this is going to be 360 minus 227, which is 133 degrees. Now we also have this nice property that the ends of the chord are going to be angle bisectors. Right? Or if you don't want to use that property, then we can go along the lines that OAB is isosceles. And we use what we did before, where we call each of these x. So I get 2x plus 133 equals 180. 2x equals 180 minus 180 minus 133, 47, so that x is 23.5 degrees, and that's this angle right here. Okay, now if I know this angle, this is hypotenuse and AC is adjacent. So from SOHCAHTOA I get cosine of 23.5 is adjacent, which is AC, over OA, or AC is OA, which is R times cosine of 23.5 degrees What's the radius? Radius is 34.125 times cosine of 23.5 is 31.29 feet, which means AB is going to be twice that, so it's 2 times AC, it's 2 times 31.29, 62.58 feet. Okay, that's it for day 1 videos. I'll post another video after I look at the textbook. This problem is from the textbook. Maybe I copied something wrong. Yeah. All right.